Chapter 3 focuses on building a nature positive society. Obviously, it's a concept and hopefully it doesn't become a cliche like somewhat sustainability has ended up becoming, but still it's worth looking at what the ideas are in terms of bringing about transformational changes to head towards a society that is basically taking things out of nature but trying to then build a nature positive society. As I said, we have a podcast before where we looked at this concept. What does it say? We know that the health of our planet is declining, and we know why. We also know that we have the knowledge and means to address climate change and biodiversity loss. First, we explore how values, rights, and norms can take center stage in decision and policy making to drive transformative change we need. So it's not just leading by science and technology, but to put people first and think about values, rights, and norms, intrinsic values, and people's moral concerns and triggers for action, etc. In addition, we consider models and scenarios which help us to imagine the future and understand what role economics, technology, consumption, and production should also play. In the Amazon and Congo Basin, 2 pilot initiatives are taking their first step to turn theory into practice. As I said again, I'm not going through the case studies, but you should definitely look up the report, which is a beautiful report for those examples. So looking at some of the rates at which changes are happening, global ecological footprint and biocapacity from 1961 to 2022 in global hectares per person. So the blue line is the total ecological footprint per person. Pink line is the carbon footprint per person, a subset of ecological footprint, obviously. Green line shows the biocapacity per person. Results for 2019 to 2022 are nowcast estimates, which means the data was not there yet. Results, okay. Remaining data points are directly taken from the national footprint and biocapacity accounts 2022 edition. So I think you have an intuition about what biocapacity is. So we are looking at ecological footprint. Global hectares per person has remained somewhat flat with a slight decline, I think, due to COVID lockdown, but we are headed back up. But we have to remember these are nowcasts, so they will be revised in the next report. And the biocapacity in terms of global hectares per person has declined over this period from the 1961 to 2020, almost 2021, with nowcasts again at the end. And the carbon footprint, of course, has increased, even though it seems to have flattened a little bit, and then there was a decline due to COVID, but now we are right back to record levels. So despite the long negotiations, carbon emissions continue to be growing across the board. Breaking down the ecological footprint, you can look at a few things. Grazing land footprint measures the demand for grazing land to raise livestock for meat, dairy, leather, and wool products. We have talked about how expensive meat diets are in terms of carbon footprints, environmental footprints per calorie, but there are of course other products like leather and wool which add to these. Forest product footprint measures the demand for forests to provide fuel wood, pulp, and timber products. Fishing ground footprint measures the demand for marine and inland water ecosystems needed to restock the harvested seafood and support aquaculture, which is becoming a bigger and bigger part with its own set of issues, even though it partially takes care of the food security issues and also provides livelihoods for some of the developing countries like China and India. Cropland footprint measures the demand for land for food and fiber, feed for livestock, oil crops, and rubber. Built-up land footprint measures the demand for biologically productive areas covered by infrastructure, including roads, housing, and industrial structures. And of course, carbon footprint measures carbon emissions from fossil fuel burning and cement production, which is a significant contributor. These emissions are converted into forest areas needed to sequester the emissions not absorbed by the ocean. So ocean takes up some 26%, if I'm not mistaken. You can look up the number elsewhere. I have podcasts on that. So what else need to be taken up can be converted into offsetting kind of calculation for forest land needed. It accounts for forests' varying rates of carbon sequestration depending on the degree of human management, the type and age of forests, emissions from forest wildfires, and soil buildup and loss. So it's a nice detailed calculation there. So looking at humanity's ecological footprint by land use, we are looking at each of the categories we discussed: grazing land footprint, forest product footprint, fishing grounds, cropland, built up land, and carbon. And human ecological footprint by activities include food, housing, personal transportation, goods, and services. So you can match the numbers, but you can see that the carbon footprint is a massive part of it, 60%. And in terms of activities, food takes up a lot of it, and then comes housing, and others are not so small right behind in terms of goods and services and personal transportation. Okay, so humanity's ecological footprint by land use and by activities. Ecological footprint measures how much demand human consumption places on the biosphere and compares it to what ecosystems can renew. In 2020, the world average footprint accounts for 2.5 global hectares per person compared to 1.6 global hectares biocapacity. So what the world can carry and how much we are demanding out of the planet. Okay, so this is an average, so one has to be careful because the rich will be consuming much more than the poor, and so on. The footprint can be broken down by area categories in the outer circle, or using multi-regional input-output assessments by activity in the inner circle here. Okay, very nice calculations, but a lot of details there that I'm skipping. Looking at the maps of where this happens again to get a sense of how the poor and the rich are doing. The ecological footprint per person is a country's ecological footprint divided by its population. Obviously, you can see that North America, including US and Canada, obviously are quite high, 6.7 gigahectares per person. There are places like Greenland where there is not enough data, and to live within the means of our planet, humanity's ecological footprint would have to be lower than our planet's biocapacity, which is currently at 1.6 global hectares per person. So if a country's ecological footprint is 6.4 global hectares per person, its residents' demand on nature for food, fiber, urban areas, and carbon sequestration is 4 times more than what's available on this planet per person. For more details, see that data over there. So basically that means North America is consuming more than 4 times its fair share, but there are others. One has to be careful how they end up being so high. So you can see that Australia and some Mongolia, I think, end up being very high. Obviously, the lifestyle of Mongolians, Australians, and North Americans are not the same, so there are other details involved. And similarly here in the Persian Gulf, you get some countries. But you can see poor countries in general, the global south, having a lower footprint, ecological footprint in terms of gigahectares per person, and the rich making up more than making up for it in terms of taking up much more than their fair share. So how do you make this more equitable? So the choices we make will shape climate and biodiversity outcomes. The human drivers, indirect and direct, are looked at here in terms of population, socio-cultural, so diets and other things, economic, so you can think of the iPad model, population, affluence, and technology. So technological drivers are there. Governance drivers in terms of how environment is treated by specific societies, and the values, indigenous versus non-indigenous people, and how they value nature and resources, for example. And those are the indirect drivers. The direct drivers, of course, include fossil resource extraction, land and sea use, over exploitation, including fisheries, pollution, and invasive species, which we facilitate in various ways, even though we are probably the most invasive species of all. How do the selections affect things? In the status quo scenario, we go with current policies and values, leading to increasing pressures on climate outcomes and biodiversity outcomes. But in the transition scenario, we go for transformative change, leading to rapidly decreasing pressures. So we bend the curve on climate change and we bend the curve on biodiversity outcomes and head towards nature positive society. A role for models is considered in the report as well. So what bending the curve means for biodiversity and how to get there. This illustration uses one biodiversity indicator, which is mean species abundance MSA for one biodiversity model, Globio, I guess, averaged across 4 land use models to explain what the different scenarios mean for projected biodiversity trends and what this tells us about how to bend the curve. Okay, you can look up this paper if you want, but every time we have to map the future pathways, obviously we need models. So here is the biodiversity indicator. This is where we have been historically in terms of biodiversity indicator values, and these are the various scenarios. The historical, no action, business as usual, so we continue to crash to 2100. Increased conservation effects will bend the curve a little bit, so 2040, 2050 horizons are used here as the date when recovery begins based on these future projections with model Globio, and integrated action portfolio which combines climate and biodiversity actions. So in order to bend the curve any earlier than 2050 and minimize biodiversity losses, ambitious conservation needs to be combined with sustainable production and consumption measures, which is the yellow line. So the 2010 indicator value is shown here with this. Conservation actions are crucial, but the green line shows that they alone cannot bend the curve before 2050 and will allow much greater overall losses, and you end up with a very different biodiversity indicator value by 2100 depending on which path you take, obviously. Gray line shows that biodiversity continues to decline if we continue on our current path, and recovery loss does not begin before 2100. So by the end of this time horizon, we are still crashing. Diversifying agri-food systems leads to multiple benefits. Nonetheless, the interactions among diversification of production and other parts of the agri-food system are complex and need more attention. Again, models can help here. So this is looking at food system diversification to enhance food systems resilience and, of course, enhance food security for all and reduce emissions from food production systems, reduce waste, and so on. So levels of organization: global, continental or national, regional or landscape based, montane versus plains, riverine, and so on, and farm levels to field levels. And examples of measures one can consider: global and continental trade agreements, social safety nets, risk insurance, agroecological diversification of household earnings at farm levels, and crop variety and diversification at field levels. So the agri-food system has production, supply chain, markets, and trade and consumers, where food waste is now tremendous. I think total of 6% of the emissions come from food waste across the globe, and even developing countries like China and India waste a lot of food, which is a part of the growing middle class eating more fish and meat and so on and so forth. So these are obviously things to be taken care of. No regret decisions mostly, not in the sense that to change meat diet to a plant-based diet, behavioral changes needed. Many cultural issues are involved, but in reducing food waste, you don't have to worry about any cultural values. Everybody can be everybody can be motivated to reduce waste independent of culture, language, food habits, and so on. You also have global production diversification, which has a feedback with global trading diversification, which has a feedback with local regional trading diversification, and field, farm, landscape, region diversification. And households are involved in there. Local, regional, diet diversity is involved with feedbacks to field, farm, landscape, and so on. And you have enhanced resilience through diversification of production, trading, household related measures. You have enhanced food security and health through diversification in production, trade, and diets. And of course you have diverse global consumption patterns which keep feeding back to local, regional, diet diversity and trading diversity, etc. So these are nice schematics, but how to implement them is always a key challenge. But if you look at contribution of conservation measures to biodiversity intactness in 2050 for two contrasting conservation strategies and baseline comparison, our business as usual scenario is going to reduce mean species abundance almost continuously to 2050, whereas we can bend the curve in this case with biodiversity intactness expressed by the mean species abundance MSA indicator that we talked about from the GlobeBio model. In A, we are looking at overall global terrestrial mean species abundance. In B, did I miss that one? I think I have missed. Okay, let me stop here and come back. Sorry about that. These things happen. I'm gonna. Okay, sorry about that. Here we go. So A shows overall global terrestrial mean species abundance, and we are looking at half-Earth integrated sustainability, sharing the planet integrated sustainability, and then shared socioeconomic pathways to baseline, which is almost like business as usual, which doesn't do much. Okay, so what these things mean obviously depend on the assumptions made, which are reported in this paper, Koch et al. From 2020, that you can look up. Here we are looking at measures contributing to preventing terrestrial mean species abundance loss in 2050. So you're looking at mitigating impacts from climate change, reducing impacts from fragmentation, infrastructure, and encroachment, so forest fragmentation, habitat fragmentations, etc. Nature restoration in supporting mixed systems, which is again this scenario here, ecological restoration, expanding and improving conservation, and the baseline where you don't do much. So mean species abundance, you can see in the half-Earth integrated sustainability versus sharing the planet integrated sustainability, end up with different levels of abundance with the mix of actions here. So what do you do with these? Basically these should serve as guidance in terms of policy prescriptions or regulations or global agreements and so on, because this is not very regional. But in general, conventional conservation efforts have mainly focused on events that directly drive biodiversity loss, such as habitat loss or overexploitation of species like some fish, tuna, salmon, whatever else, or understanding the patterns causing these events, such as trends in land use over time linked to species decline, like deforestation, urbanization, coastal habitat losses, etc. While these approaches help us to react to events and anticipate and plan for them, they ignore the root causes that led to these events and patterns in the first place, the so-called indirect drivers. So typically we would have values, norms, systemic structures, and patterns, and events happen on top, and we are mostly responding to events rather than have a holistic view of understanding the underlying causes and addressing those as well. Transformative approaches, on the other hand, focus on addressing these indirect drivers, such as the systemic structures, example economics, political and social systems, and the values and norms that shape our relationship to nature. So then you are driving a focus towards people, values, norms, and of course punishments, systemic structures and patterns, and then look at how events impact the biodiversity loss and conservation efforts. So finally, this is looking at system tipping dynamics agents of change, and a mix of interventions can create enabling conditions that trigger and accelerate transformative pathways to sustainable extraction. So still exploiting biocapacity, but in a sustainable way, so that we look at sustainable extraction, production, consumption, and trade. So you can think of these as strange attractors like Sisyphus. We are pushing up the hill here, and if these mix of interventions don't work, we keep sliding back. But if we hit these, this is creating enabling conditions to climb this uphill task with mix of interventions. But if we hit this trigger of leveraging points, then we slide into the new attractor where we are the agents of change, and we have created this sustainable extraction, production, consumption, and trade system. Is it possible? There are many ideas on how socio-technical transitions, socio-economic, ecological transitions can be incentivized, exploited, and triggered in systems. Tim Lenton talks about it, and there are other papers which look at it. So this is looking at nature positive by 2030, a measurable global goal for nature. So again, looking at indicators of biology, we have come from nature positive to nature negative now in the current system. So zero net loss of nature from 2020 is the goal, so that we hit a transition point in 2030 for a transformational change to a full recovery by 2050 in terms of this indicator of biodiversity, so that we are in this nature positive situation. Sounds very schematic, but at this point there is no choice but to consider these ideas and make these things happen using all the tools we have, including indigenous knowledge and other scientific advances and technological advances we have made, along with models which are doing very well with climate projections and predictions, and then use also biodiversity kind of models, GloBio that we talked about, to create combined actions for mapping future trajectories of our biodiversity and climate. Okay.